direction to its current position. Another vector quantity is velocity. The direction tells you which way an object is going, and the magnitude tells you how fast. Meanwhile, the word scalar is just a fancy way to say number. This is in reference to their primary role in linear algebra, as covered in the following section. Scalar vector multiplication and vector addition. In linear algebra, scalars can be multiplied by vectors in order to scale them. For instance, a vector can be multiplied by the scalar 2. This has the effect of stretching the vector to double its original length, keeping its direction the same. Scalars can also be used to scale down vector, like 1/2 squishing the vector to half its original length. If a vector is multiplied by a negative scalar, it reverses direction. Multiplying a vector by -3 flips it around and triples its length. In order to multiply a scalar and a vector, simply multiply each of the vector's components by that scalar. For instance, using the vector 3, 2, scaling it by 2 yields the vector 6, 4. If you add two vectors, you get another vector. In order to add them, place the second one's tail on the first one's head, then draw the vector from the first one's tail to the second one's head. Algebraically, adding two vectors simply involves adding their components. For instance, we could try adding the vectors 2, 1 and 3, 4. Geometrically, we see that this lands us at the point 5, 5. Algebraically, 2 plus 3 is 5, and 1 plus 4 is 5. So we land at 5, 5 once again. If you prefer, you can imagine adding two vectors as traveling along the first one. Then, along the second, the total displacement resulting from the journey is the sum. Using the previous two operations, we can obtain any vector within a space by simply starting with a given finite set of vectors. For any number of dimensions n, we require exactly n vectors. Such a set of vectors is called a basis of the space, and the space itself is called the span of the basis. For simplicity, let's start with two-dimensional space. In geometric algebra, our standard basis vectors are unit vectors, having a length of 1. In 2D, these vectors are e1, pointing right, and e2, pointing up. Now, let's try to represent the vector -2, 1.5. We need to go left by 2 and up by 1.5, so the result is 2e1 plus 1.5 e2. In general, a vector v with components a1 and a2 can be written as v equals a1 times e1 plus a2 times e2. Dot product. The dot product of two vectors is the sum of the products of their corresponding components. We can illustrate with an example.